All right, welcome everybody to this course on hands-on machine learning engineering and operations. I'm looking forward to teach this class for the first time online. I know that everybody is excited to start writing some code, building stuff, but before anything, I just want to make sure that everybody is up and running, that we have access to the material, that we understand the subject we're going to be talking about here. So let's get started. First of all, I've put in here a few links to pre-reading course, some basic concepts, some more advanced concepts that everybody needs to get started. I just want to make sure that it's clear that this is not going to be an introductory data science or Python or programming course. This is going to be very hands-on modules focused on more advanced machine learning engineering concepts. So please make sure that you crunch through these before you get started so that everybody has the fundamental base to be able to digest the material we're going to cover better. Pretty important, you will see, I don't know if you're watching this from YouTube or from Udemy, basically wherever you are, you're going to get a link that sends you to a centralized Google Drive, and all of the material needed to follow the modules is going to be in this drive. Among this material is the online class setup. Definitely take some time to go through it because it shows you a bunch of things from the pre-reading themselves to the structure you can expect from the material, a small checklist to get up and running, to get the software installs and things like this. You're also going to get access to the labs from this course setup. So definitely check it out and take the time to really get onboarded before you jump into the rest of this tutorial. Once you have this done, basically you should be up and running. The last thing that comes to my mind is I want to make sure that everybody is clear on what to expect from this course. We're going to talk about the theory behind machine learning engineering and operations. We're going to tackle the main ideas. I think it's great to get some theory in, but there are a lot of other courses that really are probably better than mine for that. Here, what I really want to do is push quickly on the practical side of things, really get our hands dirty. I think getting practical is the best way to get some experience and to get some learning quickly. So I'm really going to push on the live coding sessions to give you exposure into practical machine learning code and pipelines. And all of the coding sessions that we're going to do are going to end with some kind of labs where we take the code outside of our local notebooks, local environment, local computer, and we try to really deploy things at scale, run it on more advanced, let's say, cloud technologies that allows us to build, develop, deploy our code at scale. I hope you're excited. Let's get started with the first module. Here, we're going to talk about machine learning operations in general. I'm going to try to introduce the concept, and I think that's going to be pretty useful because every time I talk about something in the later modules, we're at least all going to have the same picture in mind. So stick with me here. First of all, why is machine learning operations and engineering important, and why is it so different from traditional software engineering? Here, we're going to talk a lot about the concept of AI native applications. When I talk about this, I pretty much always refer to these applications built around the idea of having a model that solves a business problem. When you have a model that's central to your application and you build the code so that you can deploy and distribute this model, people in general talk about AI native applications. And the reason why this field is so interesting to understand is that in contrast to traditional software engineers, machine learning engineers have to deal with a lot more than just code. They have to manage the data and the models that they generate through this code. And we're going to see that this is a big chunk of what we need to be concerned with in the later modules. And traditionally, the development cycle is pretty different for machine learning engineers as well. When you go from proof of concepts to minimum viable product to productized solutions, what you have here is essentially a very iterative development cycle. You find out that you very quickly, after your first attempt basically to deploy at scale one of your solutions, you quickly realize that things do not turn out how you would have wanted them to turn out. And you don't just go back to your deployment design or to your machine learning engineering design to deploy this model. you sometimes even come back to the solution itself and realize that you have to change the whole approach to the way you solve the problem. And so all the iterative nature that you have in data science is obviously found in machine learning engineering as well. And then something we're going to talk about quite a lot throughout the different modules is the collaborations that machine learning engineers have among themselves and with other engineers and other data scientists. It's a pretty central component of the field, and you will realize that it very often requires you to be platform agnostic in the way that you build things. Not just the way that you deploy your models on cloud platforms and things like this, but really the way that you interact with people and that you build, like microservices around your solutions and things like this. So it's pretty interesting. I'll try to be quite clear and to show examples of what this collaboration looks like in practice, let's say, in the real world. I would say that this is the most important slide of the whole course, because this is the one that I want you to have every time we start a new module, and that I want you to keep in mind as we start building things, right? Because this shows you everything. We're going to go from like raw sample data to predictions. We're going to go through 4 pipelines that allows us to generate the 4 key components or the 4 key artifacts to any machine learning engineering systems. With the first pipeline, we're going to end up with what is called the feature store, which allows us to build flexibly any kind of model that we want. We're going to leverage this feature store to build our second pipeline, allowing us to generate our optimal model, which is very different from the trained model, the one that is actually deployed in the productized solution. And the final pipeline is going to go from the trained model to the predictions themselves, the predictions that are going to allow us to make better decision making. And the 4 pipelines together is really underpinning the whole development of the machine learning engineering system. We're going to talk about a bunch of other stuff, from the drifting pipeline to the experimentation pipeline and stuff like this. But really, like, if I can really emphasize one thing, is the understanding of these 4 components that are the 4 key building blocks for everything we do. Obviously, like, we can apply machine learning engineering to a lot of different industries, and in the past I've worked on pretty cool stuff regarding personalization, demand forecasting and stuff like that. Game development and the general gaming space has been by far the most challenging, interesting and cool things that I worked on. This is where we're going to spend our focus, let's say, for at least this course. Gaming offers a lot of different insight into what are needed in terms of ML systems, from the way that you build reinforcement learning models to just beat or create like virtualized version of the player so that you can play against an opponent, to the way that you can use machine learning engineering to learn about user behaviors and things like this. There's a ton of stuff that can be done, and we will focus on one aspect of this, which is building a system to play against us, basically. So what we're going to do is we're going to focus on one game that I believe has everything. Actually, I blog a lot about this because I'm a huge fan of this game. I love to play poker, bridge, chess. I'm very into everything. But this one game is one that I'm like very passionate about because it's still one game that we play in my family. It's still pretty popular in Belgium. There's a lot of different versions. The one that I'm going to show today is quite old, but it's one of the most advanced strategy games that I've encountered. And I think you're going to get a lot of this. At least this is going to be a good first step towards learning bridge if you ever want to get into contract bidding strategy games and stuff like this. So what we're going to be doing in this course is we're going to take a hand, like we're going to look at the cards that we are dealt, and we're going to see if we can build a model to give us a percentage probability that we're going to win this hand. Because if the probability is high, then we're probably going to want to play this hand. If the probability is low, then we might want to not play it. And it's all going to become clear. But essentially, that's the thing that we're going to be focusing on. So if we go here to this address where you can actually see that the game is available, if you went through the pre-course, you can read about the game, you can understand how it works. But you will see that this model is going to allow us to look at the cards that we have, send them to the model, and then get a prediction back that tells us whether we should play this hand or not. And so I want you guys to have the high-level solution blueprint in mind of what we're going to build. because it's pretty easy to get lost in the details, but it's very important to stay focused. When we get lost, at least remember what it is that we're building and why is it that we're doing it that way. And so essentially what we're going to have is we're going to have this platform or like this game online that we can look at so that we're being dealt a bunch of new hands. And we're going to provide to our model a bunch of manually inputted cards, right? Like we're just going to tell our model like, hey, I'm being dealt like the ace of clubs and the nine of hearts and the king of clubs. And based on this, I would want you to tell me whether I should play this hand or not. And so essentially what we're going to be doing, and don't worry too much about the details for now, but what we're going to be doing is we're going to deploy our model as a microservice or as a serverless solution online, which will allow us to communicate with it through an API, making just basically very simple requests saying like, hey, based on the cards that I have, could you please give me this probability that we've been talking about? And once we have this probability, we can just look it back and take a decision and choose whether we should play the game or not. And so at the low level, underpinning this system are going to be these components here that are somewhat simplified for now, but that are a pretty good flow of what's going to happen throughout this course. We're going to be doing quite a lot of iterating on feature engineering in a safe, like local environment. Up until we're pretty happy with the features that we have, we're going to be storing these features and putting them, let's say, in a feature store where we're going to have access to it in a safe and clean way. Up until the moment where we start building a model on top of these features, which we're going to manage throughout our repository of models, up until the point where we're happy with one of the models that we've built. It has good accuracy, good performance, all of this kind of stuff. And we decide to put it into production. Obviously, like putting stuff in production is most of what this course is going to be concerned with. So I'm going to talk about that quite a lot. Once it's put in there, we can serve this model and make sure that it's usable, that people can access it through the API. And then we're going to do a bunch of more things, like making sure that in the real world, when our model is not in our safe environment, in the real world, we don't deviate too much from the performance that we had forecasted we would have. And it's pretty brutal out there. Like you can come up with the best solution in like a safe local environment, only to realize that in the real world, like things are very messy and very different from what you would have expected. Because people use things differently, like the world changed very quickly, so your model can not perform however you expected it to perform in a lot of different ways. So we're going to go back to adjusting a lot of the features that we have, and we're going to see that because we build things in a productized, clean way, it's very quickly to iterate on and on until we have something that satisfies performance metric. And so if we look at the same picture, not from the process perspective, but from the technological perspective, we're going to have a stack that's pretty strong and flexible so that we can build this stuff from the management of our model in MLflow, to the deployment of the model in Google Function or even Docker, to the analytics of Drift with Airflow. We're going to be looking at a ton of technology that is very, very useful to build this end-to-end system. And so to pin this down and really make sure that you know what you're getting into if you start like following these modules, I wanted to give you like this more detailed overview of the classes that we're going to have. Class 2, 3, 4, and 5 are going to be following the pipelines, the core pipelines that we need to build stuff at scale, the feature engineering, the development, the training, and serving. We're going to be seeing a ton of live coding in our notebook so that we can really get our hands dirty. And then we're always going to see how do we deploy things, how do we scale it up, how do we not do things in our local notebooks, but do things in a cloud platform environment, so that we can do things at scale. The two things that we're going to be talking about here, drift and experimentation, are going to be coming right after. Hope that you're excited. Finally, if you follow the course setup, you should have at least this basic component up and running on your local computer. You should have your account set up for Google Cloud. You should have like a default IDE that you use to build stuff. You should have like a virtualized environments in Conda. You should have access to GitHub so that you can push your code as we build things. And please really just want to emphasize that put in a few minutes to really get these things up and running instead of skipping through them and then realizing that you need them later.